Hiya. So this is the second video to do with the sine rule. In the first video you would have been looking at finding the missing length, but with this video what we're looking at is using the sine rule to calculate a missing angle. Now in the first video I gave you the rule which is given to you in the exam, which is to say that A over sine A is equal to B over sine of B, which is equal to C over sine of C. Now, I want you to consider that. So these are just a set of fractions basically, and we're told that they're equal to each other. So I'm going to go off on a tangent to explain the next step. So that is like saying that 1/3 is the same as 2/6 and is the same as 3/9. Okay, so that's what those three fractions represent at the moment. And let's just have a look at that. So if I times this by 2, and times this by 2, yep, I get that, I get 2/6. And if I were to times it by 3 instead, 3 times by 3, does that give me 9? Yeah, it does. So all of these are what we call equivalent fractions. Now I want to ask you something. If I turned all of these fractions upside down, would they still be equal to each other? So just pause it and have a little think. So if I flipped all of the fractions upside down, would they all still be equal? Okay, so let's have a look at the answer. So if I flipped 1/3 and found the reciprocal, I'd have 3/1. The reciprocal, flipping that over, would give me 6/2. And flipping that over, the reciprocal would give me 9/3. Now, are these still equal to each other? So here, if I timed it by 2, is 3 times by 2 6? Yes, it is. Is 1 times by 2 2? Yes, it is. And on the next one, is 3 times by 3 going to give me 9? It does. And is 1 times by 3 3? It is. Now, I'm not asking you to say the following. I'm not asking you to say that 1/3 is equal to 3/1. In fact, they are not equal to each other, and I would say that they are not equal. But that isn't the question that I've asked you. The question that I've asked you is if you flip all of the fractions, does the equal sign still hold? So are they still equal to each other? And the answer is yes. So that allows us to do something with the sine formula, which is going to help us when we go to look at missing angles. I'll show you that now. So where I've got the angles missing here, so I've got this symbol theta. Okay, so it's like a 0 with a line through the middle. That's the angle theta. Now, if I have a look at the formula has the angles in the denominator. Now, if I don't flip this formula over, I'm going to have an absolute pain with doing lots of rearranging and potentially making mistakes. So what I like to do is just flip it upside down and say, okay, well, if A over sine A is equal to the rest of it, then I can say that sine A over A is equivalent to sine B over B, which is equivalent to sine C over C. And this formula, with the angle in the numerator, the top of the fraction, is going to be so much easier to work with than the other way around. So let's have a look. You know from the previous video that we want to label up the sides. So this is A, this is going to be my capital A. So they are a pair that are opposite to one another. This is B, and so this is going to be capital B, and they are another pair that are opposite to each other, because with the sine rule we're always working with those opposite pairs. Let's substitute the values in. So sine of A we don't know. I'm just going to change the A for theta. Over A, so that's 8.0, is equal to sine of B, so that's sine of 75, over B, and that's 9.0. So what I'm going to do here to make the theta the subject is multiply by 8. So they will cancel, and I'll have that sine of theta is equal to sine of 75 divided by 9 and times by 8. So pop that into your calculator now and write down the value that you get. So again, hopefully if your calculator is set to be in degrees and not radians or the G, then you should get this answer, 0.8586. Now, does that seem right? Does the angle there look like it's 0.8 degrees? Not quite. That's the value that we get for sine of theta. So sine of the angle gives us this answer. If I want to, continue to take theta to make that the subject of the formula, then I need to sort of take the inverse function here to work it out. So sine to the -1 of 0.858 blah blah blah. So here on your calculators, remember that if you want the inverse function, so this -1, you have to press shift first and then sine. And then here, when you pop in this number in, please just use the answer button on your calculator and don't round any values until you get to the very end. So your answer comes out as 59.15983, and it kind of goes on. But if we write it to one decimal place, which is reasonable in this sort of situation, will be 59.2 degrees. So that's how we calculate a missing angle. Go on to watch the rest of the video to try an example for yourself. So here we go. Here's the example. So once you finish copying in the previous example, I'd like you to have a go at this for yourself. So using that flipped over, or the reciprocal function, sine A over A, sine B over B, and sine C over C. So pause the video there, have a go at this yourself, and then check your answer in a moment. So going through and labelling it then, I'm going to say that this is A, okay, so that's the capital letter, and opposite to that then will give me this side, so I'm going to use that as lowercase a. Let's say I didn't use B this time, but I used C, just so you can see that it doesn't matter which part of the formula you use, it'll turn out the same. So that's capital C and that's lowercase c. It's quite difficult to tell them apart really. So here I'm going to have sine A over A is equal to sine C over C. So I don't know what A is, that's theta in this example. The side opposite it is 10. Okay. The reason that they've written 10.0 is just because they're expecting you to give your answer to one decimal place. So that's why they're going to the effort of writing that 0.0. And then we've got sine of 105 over 15. So rearranging this then to make theta the subject of the formula, I'm going to times both sides by 10. So sine of theta is sine of 105 over 15 times by 10. And then taking the answer to that, I'm going to raise it as an inverse sine. So here's the answer that you get, 40.1 degrees, and again that's to one decimal place. Okay, so follow the instructions and carry on to do the second part of the questions from the worksheet. Thank you.